All right. Thanks for joining, everyone. I'm sure a few more people will trickle in here in the next couple of minutes, but it's 1 o'clock, so let's go ahead and get started. Thanks for joining. My name is Ethan Rido. I'm here with Mantle. We're also here today from Mustafa from West Tech Plastics and MJ from Westminster Tool to talk about their unique experiences, which will be the majority of this presentation. But today we're talking about how Mantle and how metal 3D printing is allowing molders and toolmakers to win new business and expand their business opportunities. Just a couple of quick housekeeping here. Feel free to use that Q&A section at the bottom of your screen. At the end, we'll certainly take some time to answer any questions that you have throughout. Please throw your questions in that Q&A so it keeps them organized for us and easy for us to answer at the end. And of course, today's webinar is being recorded, and a copy of the slides and recording will be emailed to you afterwards. So if you have to drop off or anything like that, don't worry about it. We'll be sure to get you your recording quite promptly here. But let's go ahead and dive in. Quick agenda for today. I'll start with just a really brief introduction to Mantle and a little bit about the product development process. We're going to talk a lot about product development, traditional versus product development with Mantle. And that's really where we're seeing some opportunities to expand business on the molder and the toolmaker side, which is what Westminster Tool MJ is going to talk about their applications and share some case studies and examples of how they've been using Mantle to do this. Mustafa from West Tech will do the same. And then, of course, we'll answer any questions at the end of the presentation. So with that, let's go ahead and dive in. Just a quick introduction to Mantle for those of you who are not as familiar with us. The goal of Mantle is to automate your toolmaking processes. We do this by printing precision mold components that have unmatched accuracy, surface finish, and tool steel performance. By doing this, we're essentially printing mold tooling, mold inserts at the push of a button and eliminating the time, the cost, and the operations that are very costly and time-consuming in a traditional mold building process, like CAM programming, like rough milling, like hard milling, like EDM, sinker EDM specifically. And we'll look at a bunch of examples of this today, but at a high level, that's really our goal at Mantle, is to help you automate your toolmaking process and eliminate many, if not all, of those time-consuming and costly steps of a traditional. Like I mentioned, we're going to talk a little bit about the product development process because that's really where we're seeing a lot of value with Mantle early on, is allowing to accelerate this product development process with seal tools. So when we look at the product development process very early on, the process is incredibly fast. With plastic 3D printing, with computer-aided design and simulation products, you're working in days, if not hours, where you're very, very rapidly iterating on your product to get to a design, a geometry that you like and you want to start to look at. Things start to slow down when we kind of get out of this very, very early stage form and fit prototyping stage, because as you probably know, plastic 3D printed prototypes are great for form and fit. They're terrible for allowing you to understand how your actual end-use material is going to perform. It's not doing anything to validate the manufacturing process because, of course, a plastic 3D printed part is going to perform very, very different than your end-use resin or your end-use molded part. When we see our customers moving to this sort of functional validation step of the product development process, here we're validating not just the geometry, but we actually need to validate the manufacturing process and the material. A couple of different ways we see our customers doing that: machining, prototype tooling like an aluminum tool, or even a plastic 3D printed tool, going to a prototype service like Protolabs or Xometry. All of these have some pros and cons, really offsetting speed, cost, and actual validation properties. For example, machining, it's very, very fast. You can get parts maybe in a day, if not less. But of course, that's not a perfect material representation because the material didn't flow into the mold like you would have done. Doesn't do anything to help you validate your actual end-use manufacturing process of molding. Prototype tooling, an aluminum tool, not as fast as machining. It's still faster usually than a production tool, a better material representation, but it's doing nothing to validate your manufacturing process because the aluminum tools perform very differently than steel tools. Prototyping service, very fast, pretty solid material representation, but you learn nothing about your material performance in a steel tool again, and the parts generally aren't usable for certification. After that, of course, we're going to go to production. We're going to use a steel tool. It's very slow, but of course, it's a perfect material representation. It's usable for certification and allows you to validate your molding process, allows you to produce these production equivalent parts for trials. When I say validate manufacturing process, I'm talking about validating the actual injection molding process to ensure that the steel tool is going to function properly, optimize those processing parameters like temperature, pressure, cooling rates, etc. And then, of course, those steel tools can be used to run millions, if not, tens of millions of parts after that inside of production. If steel tooling is so great, steel tooling, all those benefits really outweigh the idea of machining or prototype tooling or plastic 3D printing. If steel tooling is so great, why do we not try to use it earlier in product? Why do we use that for the first prototypes? Well, as I'm sure almost all of you on this call know, the challenges of steel tooling, and then we're going to talk about how Mantle helps to solve some of those. But when we talk to our customers that are building steel tools, production tools, 12 weeks, 6 months, minimum, if some not sometimes longer, tens to hundreds of thousands of dollars, very, very hard to use, very, very hard to produce in-house because of the very, very highly skilled tool makers that are required. It takes years to train these people, and unfortunately, there's a diminishing supply of tool makers in this country that allow you to produce these production tools in-house efficiently in a short amount of time. So with all of these challenges, as I'm sure many of you on the call know, it's very, very rare to use a steel tool during the product development stage, unless it's absolutely necessary. Even though the molded part would be better than the alternatives, it's very, very rare to do this because of these incredible challenges early on. Of course, we're not just here to complain about traditional processes. We're here to talk about some of the solutions. With Mantle, you're able to do this steel tooling much earlier in the product development stage. And this is what Westech's going to talk about. This is what Westminster Tool is going to talk about, how they're using Mantle to do these early product development stage applications to get a steel tool that's much more similar to the production tool will be to do product validation. So with Mantle, fast, prototype similar costs, perfect material representation, usable for certification, and you're validating that process. And this is what we're going to kind of look at examples of today, of going directly from a plastic 3D printed part where you're still iterating in hours, but now rather than waiting weeks or months for a prototype tool or months for a production tool, we're able to rapidly iterate on a steel tool printed off Mantle. And of course, in less time and less cost. Just a couple more slides here before I turn it over to Westech and Westminster, which is really the heart of this presentation. How do we deliver this? We deliver this by printing incredible injection mold inserts with precision, flexibility, and the durability that's required for these incredibly precise applications. Surface finish, 1 to 3 micron RA, similar to a Charmy 26 or a D2 finish. You kind of get a matte finish right off the part. Not sure how well you can see my camera here, but I just have an example of a one printed insert, and you can see finish on this part is sort of a matte finish, the D2 finish. Of course, if you needed better, you could go ahead and polish these inserts, but you can mold right off the geometries as printed. Accuracy, plus or minus a thou per inch. So generally our tools are just requiring a little bit of grinding to fit and finishing up the ejector pins. Very sharp, crisp details, flexible designs incorporating conformal cooling. The tool steels that you know and are familiar with, H13 and 420 stainless steel, identical to your traditional tool steels. And again, that ease of use, push button processing to allow you to produce these very, very easily and take maybe hundreds of hours of time down to just 5 or 10 or 20 hours of tool. And of course, what does that enable? It's great to have a fancy print process that does all these great specs. But what does that ultimately mean? It means we're removing a lot of the time-consuming and costly steps involved in the toolmaking process to go directly from Mantle out of our furnace directly into the final finishing step of grinding and ejector pin refining. Again, removing those steps directly results in cost and lead time savings. And this is a lot of what MJ and Mustafa are going to cover later on. But just a couple quick examples here. An example of a prototype tool, 67% less cost, 67% less time. A tool, an insert for a dishwasher component for a manufacturing, a big molded insert here, 67% less time, 67% less cost, 71% less time. And then another packaging example here on the right from Tessie with 60% less cost. These inserts have actually run over 1.7 million cycles each to produce over 3 million parts. So that durability that I spoke to earlier. So that's just a little bit of context that I thought would be helpful to really set up some of the stuff that MJ and Mustafa are going to talk about here of accelerating that product development, engaging early on in the process, and that big picture idea. And MJ and Mustafa are going to talk to some of the specifics, how their organizations are doing this. And with that, I'll introduce MJ Belmont here. I was going to talk about a little bit from the Westminster tool side.
Yeah. Thanks, Ethan. Very much appreciate the opportunity to be here, talk to you guys about some of the experiences we've had using Mantle. For those of you who aren't really familiar with me, I've been part of the Westminster Tool team for about 9 years. I'm currently overseeing the sales, quoting, and project management. So pretty much all my engineers and the sales team, we're all working together in our double wide trailer right outside the shop floor. I came from a just a business background, zero manufacturing experience, been cross-trained in 5 different areas between design, project management, sales, a little bit of tool making. Pretty much the only thing I haven't really done was any programming or running the CNC machines. And as of this year, I just started getting into supporting our business development side for the additive side of our business with Mantle, that we've been partners with these guys since, I believe, 2019. So just a brief little bit of background about Westminster Tool for those of you guys who aren't familiar with us. One of the biggest things that we're known for isn't really our injection mold building. It's actually our culture. We are a tool builder. That is our sole focus in our business for our business. But in this industry, I know average age is kind of getting up there with a lot of the tool makers are just in this industry. So back in 2014, my president, Ray Coombs, he created this new vision toward multiple shops throughout the entire world, Europe, Japan, throughout the US, and created this new foundation of culture. And what really is based around our culture is emotional intelligence, which is basically being aware of your emotions and not thinking you're better than anyone else or anything like that. So with that foundation, that allows you to be accountable, willing to continuously improve and continuously learn. Our continuous learning is actually known nationwide. We have our own internal apprenticeship program called Westminster Academy. It has over 5,000 different lessons. With Westminster Academy, we have tremendously decreased our training time. We have people running our EDM cells within 4 months who haven't touched the EDM machine. But with that Westminster Academy, you need that continuous improvement and to continuously improve those processes. So everyone on our team here is responsible for three improvements per week, which allows us to continue to get better and faster and quicker to help deliver a better product for you guys. With that culture, we started adding more tools that will help us be valuable to our customers. So we really we focused on our engineering side. So we really focused on adding a lot of horsepower into our DFM phase. We have Moldex 3D in-house. We do reverse engineering. And then we also have a tech center with 4 different presses that range, actually 5, that range from 100 to 350 tons. With those, we have a committed partnership that's really we don't really look for customers. We're more looking for a partnership. We're keeping a constant feedback loop with our customers. Every job at the end, the toolmaker, the project manager, the designer, we all get together, go through all the different challenges we faced, and try to come up with solutions of how we can do a better job to make that better product. And then in your bottom right, there's a few awards that we've been awarded throughout this entire journey. And actually just recently, actually last night, the Coombs family won for our local state, the Hartford Business Journal Family Business of the Year for employee size 1 to 50, which was a huge honor for us. And then back at NPE, our lead designer, Keith Lesage, was awarded the Mold Designer of the Year. Just a quick example of some of the tools that we build, just some of the types. We got 2-shot micro multicam with 45-degree angles, unscrewing, both servo, hydraulic, insert molds, both with needles or extruded tubes. We've built collapsible cores, tools, and really our sweet spot are the medical industry, that you really have those complex geometries and tight tolerances with multiple different laminated inserts, and really in that 1 to 32 range. But with all these value add services and the processes and continuous improvement, we're still dealing with a challenge in our DFM phase. So we were trying to figure out what was missing. We knew 3D printing was the next best thing for this industry. And these were some of these challenges we were facing when we were getting our new jobs for these production tools. You have all of these different knowledge from the prototype phase, like what Ethan was mentioning earlier on, that we had no experience with. So that's really what got us into looking at 3D printing. We looked at multiple different companies and machines, but the one that really stood out to us was Mantle. Um, and now what I'm going to do is kind of show you some of these case studies that really proved that point. So we've gone through, so these are the 3 different areas that we use Mantle for, or where we see the benefits of Mantle, especially in our industry tool shop with the Class 101 production molds. So conformal cooling, we can get you a blank block with conformally cooled lines within a week, where typically you're looking at anywhere from 4 to 8 weeks. We can also get you that blank block at basically the price that you pay for just a traditional block that you get from at a home or something like that. We are using it for advanced prototyping. And what I really want to stress that advanced part, because we get multiple people coming to us looking for that prototyping quick, kind of like Proto Labs or aluminum, which we have found is really not the best fit. But if you need a quicker type of turnaround that has one of those nastier materials that's glass filled, carbon filled, or high temps, or that you need oil cooling with for the peaks and ultims, that's where we saw that fit. And then finally, development tools. So your bridge tooling, you're getting hardened steel H13 and 420 cavities from the Mantle printer. So you're getting production equivalent products that will allow us to take all of that information from that bridge tool and implement it before you start investing in 8, 16, 32, 64 cavity tools. So you're able to learn a lot of those lessons upfront than having to start pointing fingers in the back end once you start sampling. So this was actually one of our very first case studies that we did public. This was with a plastic compounder. They came to us with about 4 to 5 weeks before MDM West a few years ago. And they're like, hey, we have this really awesome new material. It's a bio-based material made out of castor beans, but it's 65% glass filled, and it's a nylon equivalent. What they were looking for was to be able to take like a medical type of forceps and be able to have actual examples of this resin so they can give it out, have handouts for the people coming to visit the booth and show off this new material that they created. So within 3 weeks, we reverse engineered, we designed the cavities, we printed, and then we had to do some post-processing, but we did not touch any of the molding geometry. Everything was as printed mold and geometry wise. The only thing that we had to do was square up the block, tap your water lines, EDM burn your subgate, and then wire your ejector pin holes. With that, we had very minimal witness lines or anything. Everything was aligned well, and we were molding 1,000 parts for them within 3 weeks. We just threw the cavities into our 0809 mud frame and had no issues moving forward. Those cavities were actually molded at NPE a couple months back, so they're still going even with a 65% glass filled nylon, just showing that durability with the steel, which was one of the biggest differentiators we saw with this printer. So one thing that really opened our eyes was the opportunities we were getting. All these OEMs were starting to come to us, just wanting to try out this new cool technology. So this was getting us into the doors of some of these very large OEMs like Pepsi. Also, not just Pepsi, but also medical OEMs that were getting involved, and multiple different contract manufacturers that we've been trying for years to get into, and we finally were able to get into because they heard that we had a Mantle 3D printer. So we got into Pepsi's R&D lab over in New York, where they were having issues with the bottom of their, well, this isn't the best representation, but the bottom of their blow mold bottle. They're getting, and what they found was it was more of like a heat transfer issue. So what we did was, you can see on the top right, that's actually the printed block. All we had to do was basically touch up the OD, and within 9 days, we shipped this component to them, and it actually improved and was making good parts for them without any issues. And as you can see, it's gotten over 10,000 shots, where at first they were only looking for just 1,000. But this opened up new opportunity. Yeah, we're not really in the blow molding industry, but it opened up new opportunities for us to start dealing with people inside of Pepsi, which was a huge benefit for us. Finally, the last one I'm going to talk to you guys about is actually one of our more recent / very successful ones that we did with a medical OEM last year. We actually just wrapped up the production tools with it. So we had a medical OEM come to us after learning that we have Mantle. Again, this was a medical OEM who we were trying to get into the door with since basically Ray started the company in 1999. They came to us with two parts. I'm going to focus on one of them, but they were basically what they were two medical housing pieces, the top and bottom, that came together with the latch features that you see there. What they needed was, they already got the 3D printed part trials taken care of, but now what they needed to do was start to test the resins that they were looking at for this and do their biocompatibility testing along with functionality testing. And they were not going to be able to do this with an aluminum type of tooling or proto labs. So they were really trying to get that, look for the shrink and the material performance with multiple different materials that we ended up molding on these. And of course, because this is early up in development, you need the parts quickly, right? So we came up with a solution of, okay, we'll print them, and we will throw it into we actually created a standard mold frame that we were able to utilize for this. So I mentioned earlier how not everything's a great fit with Mantle. So what made this one such a great fit? Well, first, this project was, obviously you can see just from the fine detail, there was excessive amount of sinker EDM work on this. If you have a simple open close washer, yeah, you're gonna be able to print that no problem. You probably will have to do minimum finishing, but you won't really get that cost benefit that I'm sure multiple people in the R&D are looking for. So like I mentioned, we actually just finished the production tool. So one of the things that I just was almost, I shouldn't say, that I was flabbergasted with was these production tools. After they came out of processing, I was told that both of these tools had over 40 EDM shapes. Between these two parts, we had a total of 7 electrode shapes that we had to post machine from off the Mantle printer. And the only reason why we had to post machine was because we're talking swipe by shutoffs. There were actually 64 swipe by shutoff radii that we had to fit to make sure we don't have any flash in those latching features. The other big thing that was a huge benefit that made this a great fit was the off the printer surface finish was okay. We didn't have to do any additional polishing or anything like that, which helped condense your lead time. So if you got anything that, okay, yeah, you know what, they're looking for like a C1, a B3, which this actual part, the 2D print, was calling for a C1. That's where we try to educate you guys and try to explain, hey, if you guys are looking for a quicker lead time, lower price, can you kind of sacrifice your EDM surface finish? And sure enough, this was another thing that we were able to benefit from. And finally, the last thing was the size of the part. The benefit of allowing us to print the cavity and the core in one print allowed us to get it done within 6 days. If you have a part that's too big to print both of them at the same time, then you're basically doubling your print time from 6 to 12. So having that smaller size fitting on the print bed was another benefit as well. So some of the results that we got. So to print the top and bottom cavity, you were looking at about 145-hour print time, which is about 6 days. That entire print time was unattended. All we had to do was basically throw the designed top and bottom cavities into the Mantle Lava software. Mantle does all of the all of the programming, and within 2 hours we're off and running. From there, we had to do our 32-hour sinter, which got our blocks up to the 42 Rockwell. And then once we got got the parts off the printer, you can see some of the areas that we had to do that took us about 2.5 weeks. So obviously scoring up your blocks, hard milling your primary vents, wire EDM, the ejector pin holes, and then sinker EDM, the swipe by shutoffs that were there, right? So really anything that we had to touch, you're basically talking about anything that was more like an undercut. So like your water lines, or any tight tolerances that were basically when you have to deal with tents.
MJ, on that note, we have a question here that may make sense to address now because it relates to this. Can you speak at all to how much stock you're leaving when you need to grind or to machine around? I'm sure it's geometry dependent, but someone was asking, if you need to dial in an OD, how much overprint would you include versus take off afterwards?
Yep. So typically, that's a great question. And being used to the Mantle printer, that's something we did flag when we were going through the design process. So typically what we do is about 5 to 10 thou of extra stock. Anything that we knew that we're going to have to post machine.
Awesome.
So obviously the end goal was to get parts into our customer's hand within 4 weeks, and we achieved that goal. We had parts, we were able to mold about 1,000 parts or 100 parts within 4 weeks. All of the criticals that came off of the cavities were plus or minus 3 thou. And we only had flash in one area. Ethan, if you don't mind, can you go back 1 or 2 slides that show the part or printed block? Yeah, so the flat surface that you see kind of towards the back, there was a little window up there. That was the only place that we saw any flash. We had no issues with the swipe by shutoffs or around the perimeter as well, because there was actually a step parting line at the perimeter. So you can see some of the outcomes. We molded 2 different types of material. We molded a PC ABS blend and also a straight ABS. Between that one cavity had over 7,000 shots. The customer was able to use all of those parts for their biocompatibility testing, the fit, form, and function testing. We found that the shrink was very similar to the production environment. However, we also learned that the overall length of the part was shrinking 20 thou compared to the 7 thou shrink. So that's something we were actually able to address with the production tools. I mentioned all the criticals were within spec of that plus or minus 3 thou, and we saved over 105 CNC machining hours, i.e. kind of like what I was saying with the electrode shapes. We had over 30 electrode shapes that we didn't have to use on these Mantle cavities. So obviously the customer was very happy with this. One other thing I do want to note about this, which is actually really pretty cool, that the guy who runs Mantle, he did. So once the cavities come off the printer, we always CMM inspect them to find the centrality of the part or of the block. So what we did was we actually adjust just to kind of do R&D testing on the Mantle printer to test some of the repeatability capabilities. We adjusted some of those swipe by shutoff areas in design and printed them in hopes that we'll be able to shut the cavities, the 2 halves, without any issues. And sure enough, we had no issue with it. So that was a huge learning curve for us that we were able to utilize for future projects as well. So kind of circling back of what was missing with Westminster Tool and why we added the 3D printer, this was the perfect case study to show the importance of having your class 101 or whoever's going to build your production tool being involved in your front end. We learned that we needed A-side ejection on this part. Originally, we just printed it and we said, okay, no issues. As soon as we put it in the press, the part was sticking to the A half. So we were able to add this to the cavities, or the advanced prototype cavities. We are able to use all those lessons learned as well in our design phase, lowering our design hours and cost. Um, and then finally, we were able to build a more robust steel safe strategy because we found there were some sink areas, there was a little bit of warp. We were able to flag those up front, address them in our DFM phase and prelim and design phase, and feel very confident moving forward with these production tools. So overall, this was a huge win for us and also a huge win for Mantle slash also the OEM, because now we are utilizing all of this technology moving forward, and we got ourselves in the door with multiple different OEMs, contract manufacturers.
Awesome. Thanks so much for that, MJ. If while I have you here, a couple more questions that have come in that might as well address now.
Sure.
A question about ejector pins and lifter holes. When do you print those in? When do you print pilot holes? When do you leave them out? Any insight into that?
Ejector pin holes, we pretty much will always have a starter hole, unless if you're talking about like a pretty, I don't know if we have a limit, but if you're talking like a 64th, we might not. We might just hole pop it at that point. Lifter holes, I can't say we've ever ran into a scenario with a lifter hole, but from my knowledge or experience, I would say we probably wouldn't even put in a lifter hole. We'd probably just take care of it post machining, just due to your 45-degree angles and stuff.
Yeah, absolutely. Another question here about just the part size. Can you speak to the size of these inserts? That's something we should have included here as a scale. Do you have a rough size of how big these inserts are?
Yeah.
Oh yeah, that's great.
I would say this was probably about 3 inches by 3 by 5, maybe 2 by 5. I don't have the exact. I'm sorry.
Yeah, that's okay. But that was good. It looked like the size of a dollar bill almost, or a little bit
Yeah.
bigger than a dollar bill. And,
Yep. I would say a little bit larger than a dollar bill.
cool. And then one more here before we move on to talking about Westech. But you talk a little bit about how Westminster Tool designs conformal cooling lines and has incorporated those. I know we didn't talk a couple examples of that actually. We had.
So can you say that again? How do we?
Yeah, I think you guys use Moldex 3D, right? But I'm just given how you're designing conformal cooling.
Primarily what we do is we focus on the trouble areas that we find. So if you got thick sections, or if it's an existing tool that the exact area, so we'll start running multiple different waterline configurations in Moldex 3D, and basically we'll keep challenging that area until we don't see any more benefits in Moldex. And from there, that's when we say, okay, this is our best solution. So it's really just focusing on those trouble areas that we're looking for and coming up with whatever crazy different conformal cooling lines. I will say, we did test the limits on conformal cooling with the Mantle printer. I wish I put a slide or had a picture of it. But it was very impressive, the conformal cooling lines that this printer could hold.
Awesome. And then one more question here before we move on. Sorry, there's some good ones that I think are worth addressing. Is
no problem.
How well your experience with Mantle so far, and how well the tolerance has been compared to what's expected in terms of, obviously, it's entering the part shrinks and that's where we're losing our tolerance. But how well you found that? I know you said on these inserts everything was plus or minus 3 thou, but how have you found the tolerance? Is it predictable or expected?
Yeah, the tolerances have been great part geometry wise after we were able to square up the blocks and everything like that. In fact, the medical forceps, the very first example I talked about, everything was plus or minus, was within 7/10 of nominal. Let's see. I would say the biggest challenge that we have is just I think it's with every single 3D printing technology, is finding the centrality of your block. But once you find that, we came up with our own internal process of finding the centrality of the block that has helped us tremendously. So from that, it's just kind of a learning curve. I don't know if that answered the question.
No, it does. That's great. Awesome. Thanks. Thanks a bunch, MJ. And
My
Mustafa,
pleasure,
would
guys.
love to hear a little bit about Westech Plastics and how you guys are utilizing this technology. Thanks.
Yeah, thank you, Ethan. Thank you, MJ. Good morning, good afternoon, good evening, everyone. My name is Mustafa. I'm the Director of Business Development for Westech Plastics. I wanted to take a little time just to introduce everybody to Westech. If you're not familiar with Westech, Westech is located in the San Francisco Bay Area, and we're a tool maker, an injection molder, and a contract manufacturer. We've been in business for 54 years, supporting the life science industry, medical device, biotech, pharmaceutical. We also do aerospace and defense, food and beverage, consumer products. We touch a lot of different industries, but a little different than Westminster. We primarily focus on injection molding. We have a full service tool room in-house where we have the ability to build molds, but most of our tooling comes from offshore. And we also work with domestic tool makers for projects that require domestic tooling. Currently, we have 23 injection molding machines ranging from 28 to 610 tons. And we do insert molding, over molding, two-shot molding, and we have ISO class 6, 7, and 8 clean rooms throughout our facility for injection molding and contract manufacturing purposes. So, there's multiple reasons why we partnered with Mantle. Luckily for us, Mantle is a 45-minute drive away from us. So we work really closely with their team and collaborating and supporting new projects. But one of the main reasons was to free up our tool makers from building tools, in-house. The tooling team is not large, and they primarily support production. So they're doing preventative maintenance, they're doing repairs, they're doing modifications, and having the Mantle system in-house allows our team to print inserts, core and cavities, and utilize their time to support manufacturing. And, the other main reason we brought in the Mantle technology was because of the speed, which I'll touch on more on the following slide. But having the speed allows us to quickly support customers, win new business, differentiate ourselves in the marketplace from everybody that's using conventional tooling. So there's a quote on the right that's very important from our president, Tammy. Tooling is the base of our company. Without quality tooling, we can't produce quality parts, but it's getting harder and harder, as we all know, to find quality tool makers. So I'll touch on some of the other aspects of the benefits of Mantle from a Westech standpoint. As you all probably know, we have strong vendors in Asia that can build high quality tools, but it can take months to get the tools from Asia here. So it takes roughly 8 weeks to produce a tool, design, DFM, tool fabrication, a week or so to ship parts to us. We inspect them, we get the parts to our customers. Every now and then there's some tooling tweaks that need to happen, some modifications. Then we have additional sampling and shipping. And so, in some cases it can take 4 months to get the tools from Asia. By having the Mantle technology in-house, in a lot of cases, we're able to print cores and cavities in-house, finish them, and we have Westech owned proprietary mold bases. So that's another advantage of to our customers, is the customer doesn't have to buy the complete mold. They can just buy the cores and cavities. We'll place them in our Westech owned mold bases, and we can go straight into production. So there's a cost savings, there's a lead time savings, and anywhere from 1 to 4 weeks, we can print inserts and get them into production. Now, ironically, we brought in the Mantle system to support our customers, our tooling and molding needs. But what we've found out throughout the last 6 months to 12 months is the more and more OEMs and molders and tool makers that find out that we have Mantle in-house, We're having a lot of companies utilize our services for printing inserts for them. So very regularly now we're printing inserts, finished or unfinished inserts for other molders throughout the country, and for OEMs that are captive molders, and for tool makers. So that's really opened our doors to working with companies throughout the country that we wouldn't have really been on their radar in the past, but now we're working for them, whether we're printing inserts and molding parts for them, or just printing inserts and sending to them unfinished, or we're printing inserts, finishing them in-house, and then sending them to our molder and OEM customers. So we're seeing a lot of different benefits of working with Mantle, not only for our own production needs, but for added revenue and supporting the tooling and molding community throughout the country. So one thing I wanted to discuss on is prototyping, and I know MJ and Ethan talked about this, but from a Westex standpoint, a lot of our customers are using proto labs for prototyping, and then they come to us for production. So one of the advantages of having the technology in-house is we're able to support our customers with prototyping, and then use the lessons learned from the prototype tool into production tooling, which I'll discuss more on the slides moving forward. But now our customers aren't having to work with multiple vendors for prototyping and production. They can come to us, we can prototype for them, and then we can go into production all with one vendor, all with one team. So customers are seeing the benefits of that, and also our customers are seeing how their resin behaves and performs in a steel prototype mold versus an aluminum prototype mold. So that's a major advantage for our customers, especially in the life sciences. To continue on that, it allows us to work with our customers early on in the development phase, the design phase. They come to us instead of going to their conventional prototyping resources. Now we're doing prototyping, and we can take the prototype mold after they've seen successful results with the prototype mold. We can utilize the prototype mold for production purposes in parallel to producing a higher cavity production tool for our customers. So we're every day, every week, every month, we're learning more and more how we can utilize the Mantle technology to support our customers, and with different methods, and continue to support our customers. So I wanted to share a few successful projects utilizing Mantle. This is an automotive component. The customer is a large global OEM household name, and they build tools themselves. They do injection molding of their products, and they learned that we have a Mantle system in-house. And what they wanted to do is they wanted to compare parts molded off of Mantle tool versus conventional tooling. So they have tooling already, they're molding parts off those tools, and they wanted to see how those parts compared to the conventional tooling and molding that they have. So what we did is we printed cores and cavities for them, we finished them, we placed those inserts in our Westex owned mold base. The customer sent us metal pins that we used for insert molding. We molded successfully for them. We sent them the parts, and they've been testing the parts, and they've had favorable results. And this being a large global OEM, I see future opportunities where we could do not only inserts for them, but also do molding for them. So that project was a very successful project. Here's another example of a medical OEM that we work with. We were in the process of going into higher cavitation tooling for them. They wanted us to build an 8-cavity mold for them. And prior to building an 8-cavity mold for them, their design team had some changes that they wanted to make, and they typically outsource their prototyping offshore. But now, since we have Mantle in-house, we were able to take their design changes, print cores and cavities for them quickly, give them molded parts, and so they can test, and they had favorable results, and then that allowed us to go into production 8-cavity tooling for them. To touch more on that project, there was a 50% cost savings versus conventional prototype tooling. It would have taken our tooling team about 40 hours in-house to produce a conventional prototype steel mold. But with the Mantle technology and printing, it only took our team about 10 hours of tooling time to produce a single cavity prototype tool for them. And then the final example I wanted to share with you guys was with a molder in Colorado called Graycon. They're a smaller molder. They don't really have the resources or the time to produce tools in-house. They found out that we have the Mantle technology, and they wanted us to print some cores and cavities for them unfinished, which we did in 5 days. So if they would have gone to Asia, it could have taken 2 to 4 months, maybe 3 to 4 months for them to produce a single cavity mold. But we were able to print cores and cavities for them in 5 days, ship it to them. They did the final touch-up work and produced parts that were successful, which helped them with their customers. And to finally touch on that, what we're learning is, in some cases, customers come to us because of the speed or the cost savings of utilizing Mantle. But what we're learning is a lot of customers are coming to us these days because of conformal cooling. So the Graycon project incorporated conformal cooling, and on this slide you can see the water channels, the water lines, and it's able to help with cycle time and improve part quality. So hopefully that helps. Please feel free to reach out to me on LinkedIn or with my email address here if you have any additional questions about Westech or our experience with Mantle. But it's been a great learning opportunity working with Mantle.
So thanks so much, Mustafa and MJ. That was super educational and hopefully valuable for everyone. And honestly, a lot of people stayed through the entire presentation, which is a good indication of how valuable it was.